In our next video, we'll describe when there's no possible solution. Given our information, it looks like we have a small side, a long side, and an angle. So this is still SSA. This is still little side, long side, and then the angle. No matter how I drew this, so I'll do 51 degrees down here. I'll do a kind of longer side next to it. We'll call this C. We'll call this 5. And we'll make this 3.5. Okay, when you have small side, long side, angle, I'm still going in this counterclockwise direction. When solving for the missing angle, the trig function might be undefined, meaning that there's no possible triangle. That means you can't create this triangle given this information. Let's see when this happens. Sine of 51 degrees divided by 3.5 is equal to the sine of angle C divided by 5. Cross multiply, divide. Here we go. 5 sine 51 divided by 3.5, 1.11. This is equal to the sine of C. Let's take the sine inverse. What happens? Error domain. The value entered is not allowed in the function. That's right. The maximum possible value for the sine, or the ratio of opposite to hypotenuse, has to be less than 1. There's no way that the opposite side is longer than the hypotenuse, because the hypotenuse has to be the largest side. There's only one instance where the opposite side and the hypotenuse are the same, and the sine value equals 1. When this happens, when you get an error, that means there's no solution. That was our last of the ambiguous cases. Sometimes there's one and only one answer. Sometimes there's an ambiguous case when you have small side, long side, and angle. Sometimes when you're in the process of solving, you get an invalid sine ratio, which won't inverse because it's out of the domain and you don't have any answers. Last thing we get to do today is to find and calculate the area of a triangle. I know you know 1/2 base times height. Well, this is a clever way of restating 1/2 the base times the height. In any triangle, like triangle A, B, and C, if we have two sides and an angle, what we get to find the area of that triangle. So let's do A and B and C. My triangle looks a little bit wobbly. Let's try to do it better, somewhat better. And side length B is 10, side length C is 14, angle A is 46 degrees. Okay, now this is interesting. I have two sides and an angle, but this is side, angle, side. So I know it's not an ambiguous case because I have side, angle, side, and side, angle, side is a congruence property. I'm supposed to do something like, if I'm solving this triangle, I'm supposed to have some information where an angle is across from a side length, and I don't have that, so I'm not here to find and solve the triangle. I'm here to find the area of this triangle. The reason why it's in the unit for sines in law of sines is because it has a sine. We're using the sine function to evaluate the area of this triangle. Okay, so this really works for side, angle, side. Find the area. What we're doing is we're going to just plug things in. The area is equal to 1/2 AB sine C. Now here's the problem. I don't have angle C. I don't have side length A. So this formula can be adjusted for the two sides and the included angle. So our formula I'm going to write is 1/2 BC sine of angle A. So I can rewrite this because the sides are not really specific. It's not a right triangle. We can switch them around. In a right triangle we could not. But as long as you have the angle included between two sides, this formula will work. So area equals 1/2. Oh, that's confusing. That's angle A. So let me put the whole word area equals 1/2 times B times C times the sine of 46 degrees. .5 times 10 times 14 times the sine of 46 degrees. Hit enter. we have the area is approximately equal to 50.354 square units squared. This would be the angle. Alright, so I'm not really sure why this works. It probably has something to do with some trigonometry. I can explain. Usually we do like 1/2 base times height. So imagine this is the height I'm going to draw of this triangle. Heights are always perpendicular to their base. So let's see why this works. Traditionally we do 1/2 the base times the height. Now we don't know what this height is, do we? 1/2 the base times the height. Now this information, 14 sine 46, that must have something to do with the height. How would I find this length given this hypotenuse and that angle? This would be the opposite side divided by the hypotenuse of this right triangle I created. So I think I could find the height by doing some clever math. Let's put it out here. The value of h, let me back it up. What I can do is the sine of 46 degrees is opposite over hypotenuse, h over 14. If I multiply both sides by 14, I get 14 sine 46 degrees. That gives me the value of h. And wouldn't you know it? That's exactly, would have worked better if you could see it. That's exactly what I had up here. So the sine of 46 degrees is opposite over hypotenuse, is h over 14. Multiply by 14, this is your height. This is the reason why it works, is because that b sine c is the same thing as the height of that triangle. In our triangle, it's really c sine a is the height of this triangle, and that formula is going to give us the same solution. So this formula works when you have two sides and the angle that's formed by those two sides, the included angle. Alright, that's about it for our third video. Good luck.